Welcome to qnawire.
Problem 11.5, we have a fire truck with a ladder that's 20 meters long. It pivots over here at point A, and it has a hydraulic thing to lift it here at point C, and we know what the angles are and how far away things are from each other, etc. So we want to find out what the force is that this hydraulic cylinder needs to exert on the ladder at this point to just begin to lift it. So if we find the value of the force here that causes the sum of the torques to be equal to 0, because if we were to include the force from this ladder and require all of the torques to add up to 0, then that if it increases beyond that by any small amount, it'll start, lifting the ladder. It would either have to be 0 or it would have to be just on the verge of lifting the ladder. So we want to start with the free body diagram of the ladder. So let's draw the ladder here as a rod. So we're told that its weight is 3,400 newtons, which acts at the center of gravity, which is halfway along it. The pin that it hinges around is going to exert horizontal and vertical forces on it. And then here will be F. This angle is 40 degrees. This is 8 meters from point A. Point C is here. And this is 10 meters from either end, so we'll just put that there for reference. So if we take the axis of rotation to be at point A, we don't care what forces the pins are exerting. So that's good, because we don't really have any good way of finding that out. We do know what the weight is and what the what the force is that's being applied, or that's what we're finding. So yeah. So the writing this out, we have that our force here times, let's call it L, is the distance here, like the LAC, times the sine of our angle here, 40 degrees, because recall that torque is a cross product, so the magnitude of it has to have the sine of the angle, because if this were acting straight up and down, then it would have, exert more of a torque than if it was acting horizontally, in which case it would exert 0 torque about this point. And so then this has to be equal to, well, mg, but it's just, we were given the weight times, that's called the length of the ladder, big L, L over 2. So if we solve this, we have F equals WL times big L over LAC sine theta. And this works out to be 6,600 newtons.